tonight. Well, if you're watching, hopefully you did as well on your test, as the students in here did. Very pleased with how they did on their tests on Friday. We're not done with the fraction chapter yet. Got just a little bit, just really two concepts left that we want to finish up. One of which is something we've already kind of touched on in the past, and then something is really just going to take a couple of concepts and mush them together, but wanted to make sure we have these concepts down. The next section in your notes is going to sound scary, because fractions in general can sound scary. I mean, if I had told you at the beginning of the year, yes, your 7th test is going to be nothing but fractions and word problems, doesn't that just sound horrifying? It really wasn't so bad. Y'all did a great job with it, but you know, well, now we get to another one of those horrifying sounding concepts, and that is complex fractions. You know, just when you thought fractions were complicated enough, now we come up with something called complex fractions. So next section in your notes. First thing I want you to write down in your notes is that a complex fraction is a fraction with fractions in it. A fraction with fractions in it. So in the numerator, you might have a fraction, or in the denominator, you might have a fraction, or both. You might have a fraction of both the numerator and denominator. And so that's what a complex fraction is. It's a fraction made up of fractions, which again just sounds absolutely terrifying. Until you remember what a fraction bar literally means. Class, what does a fraction bar mean? Divide. Division, right? Divide. So what you really have then is a fraction being divided by another fraction. And we've done that before, right? Dividing fractions is simply multiplying by the reciprocal. So the next thing I want you to write down is that a complex fraction is simply a division problem. And if you'll remember that it's essentially a division problem, it won't be quite as bad. If you remember that a complex fraction is simply a division problem, it won't seem quite as bad to you, I hope. Let me take you back to something that you would have done in your junior high days. I don't think elementary school we showed you complex fractions, but I know in junior high we did. In fact, I seem to recall, and of course I know curriculum changes a little bit, but I remember in 7th grade seeing a bulletin board up in my teacher's classroom for complex fractions. And I was like, there's a fraction with fractions in it? Oh my, what am I in for? And then it turned out not to be so bad, because if we remember that this fraction bar means divide, then the entire problem could be rewritten 1/2 divided by 1/3. Well, we did stuff like this on the test. We would have looked at that and said, no. We don't really divide, class. We multiply. And we would change this to 1/2 times 3 over 1. And we would have just gotten 3/2. Or in elementary, or junior high, rather, we would have said 1 1/2, right? So we can't leave the improper fraction because we're not cool yet. Now that we're in 9th grade, Algebra 1, we can leave that. But questions on that? Do we remember learning this in past years? Okay? So we're going to do the same thing just with algebraic expressions. So write this in your notes if you would. 16x over 3m over 14x cubed over 21 mxy. 16x over 3m over 14x cubed over 21 mxy. This is a complex fraction. How do I know it is a complex fraction, Gavin?
There's a fraction inside a fraction.
There's fractions in a fraction. That makes it complex. And I need to remember that a complex fraction, Maddie, is simply a division problem. And I also need to remember, Noah, that I never really divide fractions, So if I were to see this in my textbook, I wouldn't normally copy it down. I told you to copy it down, but normally I wouldn't want you to copy it this way. Normally I'd want you to copy it as multiplying by the reciprocal. Brecken, how do you suppose we should write this problem?
16x over 3m times 21 mxy over 14x cubed.
Perfect. How many thinking the same thing Brecken said? All right, and now we solve like we normally would. With multiplication of fractions, normally we want to factor first, right? Thoughts, Maddie? You can't factor. It was a trick question. There's no polynomials for you to factor, but if there were polynomials, we'd want to factor them. So since there are already technically factors visible, Maddie, then we want to go to canceling, which 3 and 21 to get I'm sorry? The m's cancel.
And then the x. And then 16 and 14.
Well, they do cancel, but I still have,
X squared.
yeah, okay, yeah, I don't want to forget that.
And then the 16 and 14. You get 8 and 7. And then with the top x, there's 1 and just,
There's one more thing. Anyone?
7 and 7.
The sevens, they cancel also. So what's left now, Maddie?
8 over x squared. X just 1x.
There's technically one more thing and it's kind of hiding. Anyone?
Why?
The y is kind of hiding in amongst all the cancel stuff. It's hard to see those with the monomials, just to be quite frank. Now there's one thing that we have to account for, right? If something canceled out of the denominator, we have to represent it and set it unequal to 0. Now the m is gone, right? But there's also no m's left. The book would argue we would need to specify m can't be 0. Again, I would say what m are we talking about? The x is still in the denominator, so we don't need to worry about it, but it wouldn't be wrong to say that x can't equal 0. But one more thing, remember it's a division problem, and with division we're multiplied by a reciprocal. We see that a y used to be a denominator, correct? It is now a numerator. So because it is a division problem, those things we had to remember with division of if it used to be in the bottom, now it's up in the top, even if it didn't cancel, still need to set it unequal to 0. That's the one that we have to include here. All right, questions on this problem? Questions on this one? Do we see how it's really, for the most part, at least initially, same song, second verse with division of fractions? Let's do another one of these. Write this one down if you would, please. Again, normally I wouldn't ask you to copy it as written, and in a moment we'll stop doing this, but for now, you would go and copy down an a squared plus 4a over 5a cubed over a squared negative 16 over ab negative 4b. All right. It's a complex fraction. It's a division problem, class. We're going to multiply by the reciprocal. Good, Gavin. Now, as we multiply by the reciprocal, I think we're smart enough to factor while we go. You don't have to. We could just write literally this times that. But I think we can factor as we copy it. So, Gavin, instead of writing a squared plus 4a right here in the first numerator, let's instead write
8 times the quantity a positive 4.
a times a positive 4. And of course the 5a cubed, right, it's a monomial. You don't factor a monomial. All right, then here, remember, we've got to flip it. So it's not the a squared plus 16 staying up here, it's the ab negative 4b up here. Noah, let's factor that.
B times A negative 4.
And then down here is where we'll put the a squared negative 16, but we'll put it factored, Maddie. All right, once we've done that, I'm terrible writing backhanded. Once we've done this much Brecken, now we get to, and what cancels?
A positive 4, a negative 4. The a on the 5a cubed and the a on the top. And that's it.
Well, but when we cancel this a in the top with the a cubed in the bottom, it leaves us with
5a squared.
5a squared in the bottom. All right, so what's our answer then, Brecken?
B over a squared, 5a squared.
All right, where we did cancel some things out of the denominator, didn't we? We canceled away factors, Brecken, of a negative 4, a positive 4, and a. So we need to say Good, because we canceled this a can't be 0, though it is still in the bottom, so we don't have to write that one. The a negative 4 cancels, that means a can't be 4. A positive 4 cancels, which means a can't be negative 4. And there is one more thing that needs to be set and equal to 0. Anyone?
B.
The b. Because it used to be in the denominator, it moved up to the numerator, so we also need to specify that b cannot equal 0. And so there's our answer. Again, not wrong to say that a can't be 0, just not absolutely necessary to specify. And there would be our answer. Questions on this. All right, so do we all understand how to multiply flipped, but maybe factoring at the same time because we are lazy and we want to save some steps, right? But we want to be smart about it. I think that's something that we're smart enough to handle. Questions? All right, so then this one, I want you not to copy down what I write. I want you to write it the best, easiest, fastest way. Do not copy this on your paper. But be careful as you copy factored form on your paper. I'll give you a moment to start the problem, and then we'll check and see how we did on the setup. All right, did you copy this? What I have in yellow, is this what you wrote on your paper starting out? Check to make sure. Is that what you had? Noah saying that's what he had. Okay, good, Gavin, Maddie, and Bradley. Excellent, perfect. All right, so hopefully then you canceled the x negative 1s, and hopefully you canceled the x squared and the x to leave you with an x in the denominator. And that's it. Isn't that a bummer? So what's our big, ugly answer, Gavin?
Ry times 1x negative 3 over x positive 1 times x negative 6, and x cannot equal 1 or 0, and y cannot equal 0.
Don't lose this x down here, right? So we need to make sure we include that in our answer here. We could specify x cannot be 0, but since it's still in the bottom, it's not necessary to say x can't be 0. We do have to specify x cannot be a 1. And then you're right, we also have to specify up here in the top that y cannot equal 0. So this would be our answer. Again, not wrong to say that x cannot be 0, however, that could certainly be included. How many have this answer on the problem? All right, questions on this? Questions on this? So you had the x, you just forgot to say the x. All right, questions? Now, if this were as far as it went, I would have just taught this to you and delayed the test one day, right? Because this is super easy. It gets a little bit more challenging, though, if you look at a problem like this. Copy this problem on your paper. X plus x thirds over 2 over x plus 5. x plus x thirds over 2 over x plus 5. Now, technically, class, this is a division problem. But if you were to copy it down, don't do this, you would have to put in parentheses x plus x thirds divided by 2 over x plus 5. And the reason you have to write it this way is it's not just one fraction. You have to make it one fraction. And you aren't ready to multiply by a reciprocal because this is not one fraction. Does that make sense? So if you write this key step down, you have to get one single fraction over one single fraction. You've got to get one single fraction over one single fraction. And right now you got that, right? So what we practiced with adding fractions before the test, that was our last test concept, we're going to have to do here as well. If I'll put the x over 1, do this with me, and the 5 over 1, I should be able to see that in the numerator, I have a clear common denominator. Between 1 and 3, class, the common denominator is 3. So in the numerator, draw a long line. I say long, it's not going to be super long. But in the numerator, draw one long line. And underneath it, let's put 3. Do you see I have turned the numerator into an addition problem? Right? Or rather, it already was, but I'm just solving it like an addition problem. Where here I need to multiply top and bottom class by 3. Because to make a 1 into a 3, you multiply by 3. Of course, what's you to the bottom? So that means my numerator becomes 3x. Right here, what do I need to do? Technically, yeah, multiply by 1, or really just don't do anything at all, right? Just keep the positive x. You see, it's just an addition problem, but there's a little addition problem at the top. Well, now there's a little addition problem at the bottom. So again, I need to draw one sort of long line. You want your main fraction bar to still be the longest one, just so it's a little easier to see what we're doing. And the common denominator that goes under that line, class, is going to be x. And so with the first fraction, what do I do? Nothing, just copy down the 2. But for the next fraction, I'm going to need to multiply top and bottom both class by x. So what do I copy above the line? Positive 5x. So far, so good. Now, I'm ready to multiply by the reciprocal. My first fraction pretty much just gets copied down as is, except I can combine a little right here. 3x plus x class, 4x over 3 is now my first fraction. Make sure you're copying this down as I go. The second fraction you can't combine, nor can you factor. So I'm just going to carry this over, but since I'm dividing here, I'm going to multiply by the reciprocal. So in the top, I'm going to put the, and in the bottom, we're going to put 2 plus 5x, or 5x plus 2 if you want the descending order. Main reason for descending order is for factorability, and they don't factor anyway, so I don't really care. So, final answer, well, in the top class I get, and in the denominator, I could distribute, or I could just leave 3 times 2 plus 5x. Notice nothing canceled this time, but I still have one excluded value. X, because it had been in the bottom, so I do need to specify that x cannot be 0. And there's my answer. You copied this exactly as I have it on the board, I hope. Questions on what we just did? Do you see how it's addition problem at the top to get one single fraction, addition problem at the bottom to get one single fraction. Once you have one fraction over one fraction, now you're ready to multiply by the reciprocal. Does that make sense? So what we had done here, for instance, we couldn't, or on this first problem, we couldn't do yet because it wasn't all 1 over all 1. You have to get it in that fashion. Questions? All right, turn to your textbooks. Oh, excuse me. There is one other way you could solve the same problem. So I'm going to show you one option that sometimes you may want to use. Now, the method I just showed you always works. Okay? It always works, never fails. Most of the time, this is what you're going to want to do. But mathematicians are, so we're always looking for shortcuts, right? And this is a shortcut that you may want to occasionally strategically use. Let's take a look at the same problem again. X plus x thirds over 2x plus 5. The other option, instead of getting one single fraction over one single fraction, would be to multiply everything in the top by the LCD. And everything in the bottom by that same LCD. So, but you want to get this one denominator that satisfies everybody. So I've got denominators within this of 1, 3x, and 1. What would be the one common denominator for everything, class? 3x. And if I multiply everything by 3x, well, 3x times x, class. Here, when I distribute, though, this 3 is going to cancel with this 3, isn't it? So that really I just have x times x. And notice there's not a fraction left. Now, the only reason this works is because what you do to the top, you have to do to the bottom. I'm going to go and distribute here. Well, when I distribute the 3x times the 2 over x, this x is going to cancel with to give me 6. Because the x's cancel, don't they? But then the 3x times 5 gives me, I can combine here to get 4x squared, and I can either leave 16 plus 15, or 6 plus 15x, or if I wanted to factor out a 3, I could. And notice it's the same answer. I do need to specify that denominator of x from earlier cannot be 0. So you can knock the whole mess out just by multiplying by the LCD. Now, when would you not want to use this? If you have 1, 2, 3, 4 different denominators. Do you realize how massive that LCD is going to be? It ain't worth it. Here I have very easy denominators. Something like 3x for an LCD, that's a piece of cake, right? It's super easy. But if there were polynomials and stuff in here, maybe I just back off. Okay, maybe we'll do it the other way in that case. So again, it gives you an option to strategically pick. That method is by far the most reliable. Get one fraction over one fraction, multiply by the reciprocal. It's all steps we know how to do. Shortcut that occasionally works, multiply by the LCD of the entire everything. Multiply the top, multiply the bottom. That knocks out the fractions altogether. Questions on this? All right, now let's take a look at a few more together. Page 437. Page 437 in your textbooks. Go and copy down, and I do mean copy down, number 4. Copy down number 4, 2 minus 1x over 1 plus 1x. We're going to work this both ways. Okay, just again to give you the practice of doing it both ways. So, method number 1 is to get one fraction over one fraction. The thing I would like to do first is to make sure everything looks fractiony by putting things over 1 where necessary. That's a new word I just made up. Fractiony. Adjective. Of or pertaining to a fraction? I don't know. Doesn't that Y ending mean like pertaining to or something? I don't know. Fractionally? There we go. LY I know means like pertaining to. So. All right. Or is it state quality actress old time? I can never keep those straight. I know it's one of the two because pretty much all of them are one of them. Have y'all done those yet? Or you're okay, everything I'm saying you're totally missing. Never mind. You'll understand next year. I'm a year ahead of you, my dad. All right, so scratch that from the video. We want one fraction in the top. We want one fraction in the bottom. Draw your two fraction bars. What goes under the fraction bar in the top? Maddie? And in order to make that happen, Maddie, what do I have to do here? to get, what do I have to do here? Yeah, so, all right, in the denominator, Brecken, what do I put under the fraction bar? Brecken, what do I gotta do here? To get, what do I gotta do here? Just put the 1, right? It's already good, it's already good to go. Now, I've got one fraction over one fraction. I'm ready to multiply class by the reciprocal. Noah, how do I write the problem out?
Draw a line. And then put 2x, negative x over x. And then we draw another line. And then put x on the top, and then x plus 1.
What do I put in between them?
Dot.
The multiplication dot, okay?
And then we multiply the x and the 2x.
Remember in multiplication, if we've got factors or groups, we do that first, then we try to cancel stuff, and there is something that cancels here.
The x is canceled.
Yeah, we can actually cancel out these x's to leave us with
2x negative 1 over x plus 1.
and we should specify
X cannot equal 0.
how many say that method seems pretty straightforward to me. All right, but there is another method that we could have used. The other method would be to look at everything and ask ourselves, what is the LCD of everything, Gavin?
X.
Well, that's a pretty easy denominator, isn't it? When there's an easy denominator, this is a pretty easy method to use. So we're literally going to distribute everything by an x. What do I get when I multiply the x here? And here?
Negative 1.
The x is canceled to give me a negative 1. I'm going to multiply the x here
X.
and here.
1.
The x is canceled to give me a 1. And since I had denominators of x, I no longer have just a plain old x in my denominator. This is where it's hardest to remember to set the x unequal to 0. And I'm done even faster. Questions on this? How many say, I like the first method better? How many say, I like the second method better? All right, now again, the only thing with the second method is you maybe not want to use it all the time, all right? But, so hopefully you understand the first method as well. But yeah, I think either method really not that bad, not that challenging, hopefully. A lot of places we can mess up though if we're not careful. And that's really the key to mathematics in general, right? Being careful to avoid mistakes. Go ahead and copy down number 5, but since majority like the first method, we're going to let the majority rule here on number 5. And we're going to go with method number 1 on number 5. So bear with me, Noah. We'll give you a chance on your method in just a minute, but we're going to let majority get method number, or their method for number 5. We have 1 plus 3x over 2 minus x fourths. And let's see here. Let's go to Maddie. Start us off. What do we want to do first? Good. Let's put some things over 1. I think no matter which method you're using, that's a good strategy, is put stuff over 1. Okay, then what, Maddie? Keep going. Okay. And by the way, it would not be wrong to say 4 times x positive 3 over x times 8 negative x, and just leave it in this format. This format would be fine. I don't mind this format either. Any excluded values here, Maddie? No, because the only thing that moved up was a 4, which 4 already can't be 0, so we don't even need to say anything. And there we go. Great job, Maddie, on that one. Questions from the rest of you? Were you following right along with Maddie, thinking the same thoughts? All right. Number 9, let's drop down here. And this time we're going to go to Noah, and we're going to let him do it his way. So follow along with Noah, even though it may not be your preferred method. Let's follow along with Noah anyway. Noah, why am I thinking your way might be a good choice on this particular problem? Yeah, there's only one actual denominator in the entire problem. It occurs a couple times, but there's only really one denominator, and that's the x plus 3. So, Noah, I'm going to want to multiply top and bottom by the quantity x plus 3. Now, when you're multiplying by a polynomial, you need to remember that's a distribution, right? Here, it's not really distributing because there's only one thing I'm multiplying, all right? What do we do? 4x plus 12. Ooh, careful. These are now going to cancel when we try to multiply here, so it's just
2.
All right, questions so far? Do we see how since the only denominator we have in the whole thing is x plus 3, that's the common denominator we can multiply by. We multiply x plus 3 times the 4, that's 4x plus 12. We multiply x plus 3 by a negative 2 over x plus 3. The x plus 3's effectively cancel here, so all that's left is the negative 2. All right, Noah, what about in the denominator?
2.
Right, these cancel, and all I've got is a 2. We can simplify a little bit here, Noah.
Take out the 2.
Not yet, let's combine first.
10.
There we go, let's make it a 4x positive 10 over 2.
And then take out the 2. So 8. 2x. Or 2 times 2x plus 5. Over 2.
And then,
2's cancel.
so I'm left with just.
2x plus 5.
And as far as denominators, I used to have denominators of x plus 3, didn't I? And since I used to have denominators of x plus 3, Noah, x cannot equal negative 3. All right, were we following along with where Noah was? Now, the one thing I will say, there were a couple times we had to stop along the way and say, okay, be careful with this, be careful with that. Didn't have as many of those working the other way. This is quicker, maybe more prone to error. Okay, so again, kind of juggle those options. Questions? Let's do another one. Drop down now to number 11. Drop down now to number 11. This is one I do not want to use Noah's method. There are 3 different denominators here. And when there's lots of different denominators, multiplying everything by the LCD is not my method of choice. So we got a 1 over x negative 1 plus 1 over x. And then we have a 1/3 minus x. And of course, the first thing I'll want to do here, Brecken, is put that x over 1. All right. So, let's draw our long fraction bar. And then any polynomials, you still want to factor or group them. Let me say that again. Polynomials, let's still factor or group them. So, Brecken, in the numerator, we draw a fraction bar. What goes under it? X times the quantity, x negative 1. So, first fraction, top and bottom Brecken, to get x. Second fraction bracket, top and bottom by, to get. Good, because when you distribute a positive 1 to an x negative 1, you still just get x negative 1. In the denominator bracket, let's draw a line underneath it, put 3. First fraction, just keep it. Good, next one times the 3 gives us negative 3x. There is just a little bit of combining I can do right here, Brecken. Yeah, let's replace that with a nice easy 2x. And now we're ready to change my division problem into multiplying by the, to get?
2x over x times 1 negative 1 times 3 over 1 negative 3.
And you know what? Nothing's going to cancel, right? So what I can do is just leave my answer, put the binomial in the front, and there it is. And notice all of my denominators are still denominators. The only thing that moved up was a 3, which couldn't equal 0 anyway. You see what I did here, Brecken? Erase the multiplication sign, make my fraction bar go across, monomial, polynomials, and I just erased the 3 and wrote it at the front. So everything's written correctly, boom, there's my answer. It's not pretty. I really would have liked something to cancel, but it's correct. Questions on this? All right, you're going to get a chance to practice some of these for homework this evening. For homework tonight, I need you to do page 437. Page 437, numbers 6, 10, 12, 15, 16. 6, 10, 12, 15, and 16. They're on page 437. We'll continue looking at complex fractions tomorrow. Have a wonderful rest of your day. You are dismissed.